So I think that serverless applications, right, serverless functions are one of those places where we at Fermyon, building tools like Spin, can really make some vast improvements and say, look, here's a promising first step for why WebAssembly is this kind of third wave of cloud computing.
Hey, before we get started, we want to remind you that we have a Patreon. If you want to hear the full episode, you'll have to become a member over there. You can also support us by going to our merch shop and buying one of our shirts. With that, let's get on to the episode. Hello, welcome to the DevTools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey everyone, our guest today is Matt Butcher. If you've worked with Kubernetes, there's a really good chance that you've used one of Matt's tools. Welcome, Matt. So glad to have you on. Before we start, would you like to tell our listeners a bit more about yourself?
First of all, I feel like I ought to lead with an apology for all the Kubernetes tools, but I guess the best way to describe myself is as a recovering philosopher. My original goal was to be a philosopher, like philosophy professor. I have a PhD in philosophy. I actually taught philosophy for a while. But somewhere along the line, it turns out you kind of have to pay your way through school and things like that, and philosophy might not be the highest paying job out there. I mean, it's probably close, like top 98%. No, it's nowhere near that. So I started writing code sort of in high school, carried that on in college, worked in like the computer lab at college while I'm studying philosophy. And at some point, I was kind of like, man, philosophy moves really slowly and computer science moves really fast. And I like this a lot more. So I spent, first part of my career really in more like systems engineering, then into content management systems. I did Drupal for a long time. Drupal actually got me into cloud computing. I ended up working at HP Cloud originally to do their Drupal sites and kind of finagled my way out of the Drupal world and into the OpenStack world. Absolutely fell in love with cloud and have been doing that for the last years. And then, moving close to the present, several years ago, I was at a small startup company in Boulder called Deis. We were building Kubernetes solutions. We started the Helm project and the Illustrated Children's Guide to Kubernetes. Along came Microsoft and said, hey, y'all look like a great group of people to join our brand new Kubernetes team. And so I spent about 5 years at Microsoft, really, really enjoyed it. But along the way, something else came along, this WebAssembly thing, and I'm like, oh, I gotta do this. So a bunch of us left Microsoft and started a startup. So I've been doing that since November of 2021. It's probably the fastest I've told ever told my life story, and it's actually kind of depressing when you tell it that fast.
It's good though; it's concise. It hits a lot of points.
Yeah, it's super interesting. I always love hearing about people who didn't start in computer science and then ended up in it for whatever reason, and it's awesome that you're like aiming to be a PhD, and then you're like, nah, never mind. I'll just do computers.
I got through the part where I had to pay for all of that, and then it was when I decided I didn't want to do it. So Kubernetes, right? If we talk about Kubernetes in context of what we were trying to solve, right? We've got this first wave of cloud computing that comes along, right? Virtual machines. And all of a sudden, we're all kind of collectively going through that aha moment of going, oh, right. So I can take my operating system and I can kind of like package it up and lease somebody else's hardware. And they're going to do the part I hate doing. And I'm just going to keep shipping my operating system image up there every time. And we're all kind of, absolutely in love with this idea because it means we're not slaves to the blinky lights in the data center anymore. And then we start to fall out of love with the thing that we were once passionate about, right? For me, it was like, I cannot believe I just spent 3 hours building this image, pushing it up into the registry, and now I realize that I forgot to include curl. So I'm going to have to do the entire thing again. And at the same time, we're dealing with orchestration system, developer tool or DevOps tooling like Chef and Puppet. And again, we're kind of feeling the same way. Hey, this is great. I can write procedural code, and instead of writing a whole bunch of commands, I can just kind of enshrine all of this in Ruby, right, or Python, and suddenly it feels the same. It feels like the same kind of artifact as my application. And then along comes this next shift, right? And containers become a thing, and we start to fall in love with the lighter, the little svelte container that feels so much smaller than the gigantic virtual machine image I was building. And this, Kubernetes comes along, and the orchestration model looks so much more attractive. And suddenly we're talking about declarative. And declarative is the best thing ever because procedural is so yesterday. I used to have to write this ugly old Ruby code in order to describe what my architecture looks like. And now all I do is write this beautiful YAML. We kind of go through these funny phases. Again, every time, to me, it's like I found the last tool I'll ever need. This is the best thing I've ever found. This will solve all of the world's problem. Let me tell you why Kubernetes is going to make you a happier person. And then a few years later, like now, I'm like, if I never see a YAML file again, I will be happy. Declarative, it's so much of a pain to use declarative infrastructure. And, the wheel moves on, I guess.
Indeed. The cycle continues.
Yeah.
Yeah, so earlier you mentioned that you've worked on a bunch of different Kubernetes pieces of tooling. So, what are those, and what do they help you do?
Kind of the big ones. So to give a little bit of context, I talk about moving from the virtual machine world into the container world. I started working at Deis. Deis was building a platform as a service. We wanted to build the open source competitor to Heroku. And we wanted to do it using containers, which were, of course, the newest, shiniest thing in view at the moment. And it was going great. And we were really excited about what we were building. We were using build packs just like Heroku. And then Kubernetes landed, was made public. And we looked at it. And I had come from Google prior to that one. So there was a sense in which looking at it was like, oh, hello, Borg, old friend, right? And in a sense, it was also like, oh, I understand right away why this would be a really powerful way to orchestrate our stuff in our platform as a service thing, right? This is gonna be what sets us apart from Heroku. We'll have containers, we'll orchestrate them. We won't have sort of the startup time problems that Heroku at that time was having. And then we got working on Kubernetes and realized that it was actually kind of hard to install things into Kubernetes. You ended up having to write a YAML file for each different artifact you wanted to describe. So if it's a service gateway, you're writing a service. If it's a piece of secret data, you're writing a secret YAML file. You need replica sets or at the time replication controllers, and then later on deployments and all this. And we're writing a lot of YAML. And I was writing the same YAML-y objects over and over again to try and install the latest version of our platform into Kubernetes. And we had a hackathon, a company hackathon, as part of sort of an all-hands meeting. And so I came into that frustrated with not wanting to write the same YAML anymore. And got together with a couple of other people at Deis who were also similarly. One of them was looking at Kubernetes, and the other one was kind of working on something vaguely NPM-ish at the time. And we're kind of chatting together and going, we could build a package manager for Kubernetes. So we built this package manager called Kate's Place. This was our entry for our hackathon project, where the prize was a $75 Amazon gift card. And we're like, we are going to win that gift card. Nothing is going to stop us. We go out for the team dinner, and we're like, all right, well, we finished the main course. Do you think we can kind of sneak out and go work on our package manager? So we wrote this package manager called Kate's Place that was sort of approximately modeled on, a little, 1 teaspoon of NPM, a couple tablespoons of apt-get. And we got to the show and tell thing, and we got up there and demoed Kate's Place, and everybody was like, yeah, that's neat. And we did end up winning the $75 gift card. We split it 3 ways. I blew mine on coffee, and I am not ashamed to admit that. So the day after that, the CEO and so the offsite's all done, and the dust has settled, and the CEO and CTO call me. And I'm like, uh-oh, when the CEO and CTO call you at the same time, you're in trouble for something. And I'm thinking, did I do anything at the offsite? I don't know. And they're going, so that thing, that demo you did, the little package manager thing? And I'm like, yeah. And they're like, we think there's some potential for that. And I'm like, oh, good. And they're like, we think you should start working on that. Like, stop working on the paths so much and really kind of pivot over and work on that thing. And I said, oh, good. And they said, there's just one thing. We really don't like the Kate's Place name. They're like, it sounds like a coffee shop. And I'm like, I know, right? Doesn't it sound pleasant? Isn't that like the coffee shop? They're like, no. So I called Jack Francis, one of the other two guys that I was working on along with Remus, called Jack Francis, and I'm like, I got good news and bad news. The good news is we can work on this Kate's Place thing, forever. And the bad news is we have to come up with a new name, and they kind of want it to be, Kubernetes-ish. So we sat around with a nautical dictionary, just on the phone together, reading each other entries out of a nautical dictionary back and forth. It's like mast, nope. Captain, well, that's actually what Kubernetes means. And we're just kind of back and forth. In Jack's version of the story, we said the same word at the same time, but really Jack said it and I probably just repeated it back. He's like, what about Helm? And I'm like, oh, yeah. So we renamed the package manager Helm, started working on that, and the project kind of grew by leaps and bounds, well beyond what we thought it would ever become. I think at this point it's probably 70-ish% of Kubernetes users use Helm to install Helm charts, also from the Nautical Dictionary, which were really, a great way to solve that problem that I had at the beginning. You can encapsulate your YAML files, you can templatize them, then you don't have to write nearly as much YAML in order to use Kubernetes, and hopefully the world was a slightly better place.
There's two lessons here. Good things come from hackathons.
Yep.
And pick a theme; it'll make things easier to name.
Worked for Ruby and that whole ecosystem, right?
Yeah.
So, yeah.
Back when I worked at Artsy, it was physics and art terms. So we had like a list of physics things. So we had like metaphysics was our GraphQL service, and Force was the HTTP service, and yeah.
But I mean, I got to say, the Java ecosystem, as it got going, the number of bad coffee metaphors, we might have actually passed some kind of threshold after which every new project, it was like, I don't think Frappuccino should be the name of the thing.
Yeah, I think CoffeeScript killed all of that.
We over caffeinated at that point. Yeah.
Yeah.
Well, I guess we had Java, then JavaScript, then coffee. Yeah. We really leaned hard into the caffeinated beverage thing for a while.
I think the trick for the philosophy behind naming things is that the names have to be differentiable in some meaningful way. So if you can tie loose logical analogy to like these two things, but when it's just like a bunch of like nouns for drinks or whatever, it's much harder to say, yeah, this drink kind of represents this like web service,
Yeah, I mean, it gets to be a stretch really at some point. We used to have an inside joke at Deis that we would substitute out the word coffee with the word slurm. And it was like one of those things where the sort of onomatopoetic sound behind slurm just sounds so gross that kind of makes you shiver a little bit. I don't know, was slurm from Futurama? I think it might have been from Futurama.
Yeah, I think
I'm not even entirely sure
yeah.
what the origin of that was.
So I want us to transition to talk about Spin a little bit, but before we do that, so Kubernetes is like infamous for both being like incredibly helpful, but also pretty hard to wrap your head around and like all of its facets and really get into the weeds. Something that I love is that you helped co-author like illustrated children's guide to Kubernetes, and I'm like super curious, like how did that come about? Like who was like, you know what, we need to make a children's book out of this, that'll help.
I mean, that's often the solution to life's problems. I am not kidding you when I say this. The illustrated children's guide to Kubernetes happened the same day that Helm did. So
wow.
in this whole offsite that we were having, where we had the hackathon, the CTO and I and a few others had been evaluating Kubernetes as the platform to pivot to, and yet there was still a huge contingency at the company that had never heard of Kubernetes, and of course, I mean, even the word itself is so clumsy that in order to get people kind of engaged in this, it's a difficulty, right? So Gabe, who's the CTO, comes up to me and says, yeah, I'd really like you to introduce Kubernetes to everyone during the offsite. And I said, okay, like all of engineering? And he says, oh, no. When I say everyone, I mean like marketing is going to be in the room, finance is going to be there. I mean, just kind of introduce it to everybody. And I said, oh, okay.
No
and
pressure.
He said, but don't worry, I got you covered. I'm going to give you the slot right after lunch. And I'm like, the slot when everybody's falling asleep right after they had a really big meal. That'll be great, Gabe. That'll be great. So the night before I had to give this presentation, I'm just kind of like trying to build some kind of presentation to articulate even what Kubernetes was, let alone the value of Kubernetes, in this kind of generic way. And I have 3 daughters, and I don't know what the moment was, but I'm like, it would be really funny if I took a couple of the kids' stuffed animals and took pictures of them and made up a story about a little PHP program called Fippy the Giraffe who was trying to get deployed on Kubernetes. And so I took a couple of pictures. I wrote this really, really bad PowerPoint presentation, but it was essentially the text of the Illustrated Children's Guide of Kubernetes. And during lunch, I grabbed a big old poofy chair from another room in the hotel where we were doing the conference, dragged it across the lobby into the room and put it up in the front and sat in the front like I was reading a story and projected this slideshow behind me and gave the first version of the Illustrated Children's Guide of Kubernetes. Now, marketing was in the room.
Story.
Yeah. So marketing is in the room watching this presentation. And Karen Chu is watching the presentation, kind of nodding along. And I didn't know if I'd kind of reached, I don't know. I had no idea whether I had done a good job. It was a really rinky-dink presentation, right? There really was nothing special about this. A couple of weeks later, Karen calls me and says, hey, you know that slide deck you showed at the offsite? I have this wild idea. What if we really made a kid's book out of it? And what if we, use this as marketing material? We could give it away at KubeCon, which the very first KubeCon was coming up only a couple of months away. This would be a great way to get people enthusiastic about Kubernetes. We could mail it to people. And she's like, I've already lined up an artist. I'm working on some storyboards. Thankfully, she's much better at all of these things than I am, because otherwise you'd be looking at this kind of funny looking giraffe. And Karen is brilliant. Before asking the illustrator to design the giraffe, we're Deis. We're on a shoestring budget. We can't afford a lot of stuff, but she really wanted to have a giveaway to go along with the book. So she goes and finds all the places that can source little squishy toys in the shape of, giraffes and owls and the characters in the book, and finds some that look, appropriately squishy and kind of cartoonish, and then sends our illustrator those and says, can you just kind of riff on these so that they'd be close enough to your illustrations that we could give these out. And so we kind of launched the book as a little bootstrap startup with, an illustrated book along with, a line of toys to go with it. And we gave those away at the first KubeCon, and it just kind of took off from there. I think at this point there were several books. When Microsoft acquired Deis, CNCF reached out and said, would you be willing to donate Fippy and that whole kind of illustrated children's guide to CNCF so that we could use it as more like a mascot? And Karen and I were very enthusiastic about that, and Microsoft actually was very enthusiastic about that too, because they had really started investing in CNCF in the Kubernetes space, and so gradually we got to kind of turn things over to CNCF, which in and of itself was really exciting. And now there are all these other illustrated children's guide books, illustrated by different people, written by different people, and it's always fun to kind of see this and go, yep, that silly little after lunch presentation. It just took the right person in the audience to see that and go, we could really do a lot with that. So it's been kind of a wild ride. And it's like, okay, so I'm proud of the code for Helm, right? And I feel like I should view the Illustrated Children's Guide as a thing to be just a little bit embarrassed about, but I'm not. I think I actually am more proud of the Illustrated Children's Guide at this point than any piece of code I've ever written in my life.
Well, you can look back on the children's book and go, oh, that was fun. You can look back on your old code and go, oh, God, what was I doing?
Yeah. You are not wrong. I mean, that is totally why that's the case. It's like the stuffed animals are still cuddly. The code, yeah, it's just prickly all the way at this point. It's like, oh my goodness. I wonder why we have that feeling about our code. I mean, every engineer I've ever talked to is like, I get embarrassed about the code I wrote back then. Do we really learn so fast that the code from only 6 months or a year ago is that embarrassing? It really seems to be the case, in which case, that says something about human beings and our ability to improve, or at least human beings and our ability to cast shade on things we've already done.
I think it's in part maybe that our taste over time changes. Not that something is objectively good or bad, because you're generally, as you look at code from another person, you might say, oh, this isn't how I would write it, but like it's not my code, so it doesn't matter.
Yeah.
But when you look back on your old code, you're like, I have this taste now and I wrote it that way and I would never write it that way now. And like, why did I do that?
I don't think we acknowledge how judgmental we are about ourselves. Past me was such an idiot, but present me, I'm great.
Speaking of present you, let's stop talking about what you have done. Let's talk about what you are doing. So the newest open source project you've been heading, and which is the like underlying tool for Fermyon, is Spin. So what is Spin, and what prompted you and your team to build it?
So Spin is a developer tool for building serverless applications using WebAssembly. And I'll just kind of unpack all of that, but really with the story of why we decided this was even remotely a good idea to try and do this kind of thing. I mean, WebAssembly. So let's start with WebAssembly, right? Just as a technology. We've had the browser for quite a while now. One language has done has really kind of amassed. You might have noticed there was a language that amassed kind of a following in the browser world and kind of broke out from there. JavaScript, something like that. I can't remember the name of it, but others have failed, right? Java applets, which were really kind of the first other language to be embedded inside of the browser, came and went. VB-script had a brief stint in the browser. Silverlight, Flash. We tried all of these different techniques for extending the way that we wrote software inside the browser, and it's seemingly time and again these technologies failed, right? For one reason or another, each of these technologies failed. Yet we still like the idea of actually being able to run something else inside of the browser. Must have been around 2015, the team at Mozilla kind of introduced their version of what would be a really interesting way of extending the browser to run something other than JavaScript. And rather than try and tackle the sort of soup to nuts story that applets and Silverlight and all of these did, where it was really all about building code and then, owning a piece of the UI and being able to paint widgetry of your preferred kind of there, WebAssembly really started more modestly. WebAssembly really started more modestly by saying, the developers said, let's just figure out a way to execute different languages in the browser, which means really we need to build sort of a language style virtual machine of the sort that you get in Java or .NET. But whatever the characteristics of this runtime are, it needs to be able to do a couple of things really well. And the first one is going to be, it's got to be able to interact with JavaScript. It's got to be able to interact with its environment so that we can call in and out of these binaries from JavaScript. The second one was that it had to have a really excellent security sandbox model, because as we all know from using the internet, it is not entirely a safe place, and people try and do dastardly things with your computer. And so they really wanted an even stronger security sandbox model than what you get in JavaScript. And then they wanted kind of a binary format that was going to be lightweight and easy to move around, fast to load, fast to start execution, because we are very, very attention-deprived people who wait about 100 milliseconds before we start getting grouchy that we're looking at a white screen. And so these kind of characteristics were the driving force behind the original WebAssembly specification. Now, Mozilla did a couple of things that were really smart here. First one is, in my opinion, they didn't try and tackle the UI layer too, right? They just said, look, we'll make it interact with JavaScript. JavaScript can do all the DOM goodness, and we won't have to invent another, abstract windowing toolkit like Java had or the whole kind of Flash thing. The second one was that they decided that this road was best traversed with friends. And so they enlisted the Chrome team, the Safari team, the IE team at the time, and got everybody sort of in on the idea that they would standardize it under W3, just like HTML and CSS, and then everybody could collectively work in lockstep to introduce support into the browser. So that was WebAssembly. So let's just put WebAssembly on a shelf for a moment and go back to Kubernetes. That's where we all want to talk more about. More YAML. So we're working in Microsoft now after Deis has been acquired, working inside of the container team in Azure. And I had what I swear is the best job at Microsoft. My job was to build open source software that exhibited how containers and Kubernetes were going to solve your problems. And so along with Helm, we just kind of kept dropping one after another a bunch of interesting, what we thought were interesting open source projects, things like Brigade that were really more like ETL pipeline kind of thing, and CNAB, which is a way to package stuff. And we would contribute these up to Linux Foundation or CNCF, whatever sort of made sense. And the way we got inspired was to go out there and talk to people and say, what do you wish you could do with containers? At KubeCons, go out to customers of Microsoft's or chat with other teams inside of Microsoft. When you ask questions like that, you're going to get some good ideas. But sometimes you're not going to get good ideas. You're just going to have problems you can't figure out how to solve. And we started to amass a number of those problems. One of them was that we really wanted to figure out a way to sort of instantly scale up and down. So when you think about Kubernetes, right, I deploy my little application into Kubernetes. And in order to make sure that this application is always going to be available, I want to have, 3 or 5 or 7 or 9 replicas running somewhere in my Kubernetes cluster so that if a node or 2 or 7 die, I still have a version of my application. Or so that if, suddenly we trend on Hacker News and we get tens of thousands of requests coming in all at once, I don't have to start denying service to some of them, right? Things are just pre-scaled so that I can handle the load. And this solves really kind of 2 big problems, right? The outage problem and the scalability problem. But it's wasteful. And that's a problem for me as a consumer because it means I'm paying for 3 or 5 or 7 or 9 instances of my app running instead of paying for 1 instance of my app running. Or at 2 a.m. when nobody's visiting my app, I'm still paying for 3 or 5 or 7 or 9 of these things even when nobody is looking at or using my app. So what we wanted to be able to do was figure out a way where we could scale down, ideally to 0. When the app is not being used, nothing's running. When traffic starts to come in, I start up an instance. If a node dies, I start up another instance somewhere else, but I'm not running all of these things all of the time. So we tried various ways to do this with containers and with virtual machines, and we were just kind of drawing a blank. We just couldn't find a way to make containers start fast enough that they could do the work we wanted them to do without making the sacrifice that in order to start a container that fast, there was nothing worth having inside of the container, right? So really we were looking at seconds to start a container when, as we talked about a couple of minutes ago, right, your users got an attention span of 100 milliseconds. So they're not going to wait for 5 seconds or 12 seconds or whatever for your container to start up when they come in and you're in the scale up motion. So that was kind of the first catalyst, and there were several others. We were frustrated by the fact that Docker containers were not cross-architecture and cross-platform, and especially as ARM processors got more popular in the data center, we're like, here we are at Microsoft telling people, okay, well, if you want Windows container support and Linux container support and Intel support and ARM support, then here's what you do. You build yourself a matrix, right? You're compiling and building these things for all. Oh, and you're going to need different Docker files because ARM libraries are slightly different than Intel libraries on Linux and Windows obviously different. And this was a really frustrating story to try and tell, right? It was obviously frustrating to everybody, right? When you think about it in the contemporary platform engineering world, right? Platform engineers are going, well, if only we had an ARM version of this, we could run it a lot cheaper. Well, that means we have to throw it back over the wall to the developers who are like, are you kidding me? Now I have to build a container on an architecture I don't even have anywhere. And you're just introducing friction all along both the development pipeline and the social pipeline inside of an organization. So we're looking at problems like that, scale to 0, cross-platform, cross-architecture, performance, some of these kinds of things, and just making no headway in the container ecosystem.
What was the time frame on this?
Oh, this was 2018 was when we were really kind of working hard on these problems. And we all got together we worked as a distributed team. We were Deis Labs when we were at Microsoft. It was about half of the Deis engineers became Deis Labs. And then we just kind of kept pulling in people that we like to work with and growing the team that way. So in 2018, we were up on Vancouver Island, in fact, for an offsite meeting, and we had finished a day of planning and we'd finished dinner, and we were just kind of sitting around chilling after this, venting about the many issues we were going to have to solve in Helm, right? Things like that. And somehow the conversation sort of turned to these problems that were feeling intractable. And we're in, you get that moment where you click into kind of the creative mode and you're not thinking about problem solving in the sense of applying existing patterns, but you start going, well, what if, just throwing out an idea here. What if there was some other cloud runtime in addition to virtual machines and containers that we could draw from? What would that runtime have to look like? Well, it would have to have a really good security model, because that's just table stakes for the cloud. Isolation is what makes compute the kind of thing it is. It'd also have to be really high performance, because we know we need to be able to start things up in under 100 milliseconds. It'd also have to be able to load really quickly. It'd have to be cross-platform, cross-architecture. And, this is how we'd want to be able to use it. And we're kind of talking through that. And then started going, we should look into this. Maybe there's some technology out there. Maybe we don't have to invent this. Maybe there's a technology out there that'll accomplish this for us. We had Research Friday time, which was basically each person could kind of do their own research on Friday. But several of us started looking into technologies, WebAssembly being really one of the first ones that we looked at, and going, well, do any of these fit that bill? High performance, cross-platform, scalability. And over, we tried all these wacky experiments with WebAssembly, and each time it seemed to be working out. And we did some things that were false starts and went, okay, well, that's not the right way to use this technology. But we really realized that we could kind of pluck WebAssembly out of the browser, drop it into a cloud environment, and all those virtues that WebAssembly had in the browser, the strong security sandbox, the easy ability to call in and out of the binary, the compact binary format that was portable across architectures and operating systems, those were exactly the things that we needed to make a cloud runtime work for us. So, and we discovered that there were indeed some engineers at Mozilla, some engineers at Fastly who were all working on kind of similar stuff, and we pooled resources together. They were building a runtime called WASM time that was a great, standards compliant, really kind of cutting edge, staying along with the standards as they emerged. And it was a great WebAssembly runtime for us to start with, and we began kind of building experiments. At this point, we started going, all right, we're well out of our Microsoft mandate of building cool container technologies for Kubernetes. And we decided it was time to kind of pack up, try the startup thing. And 10 of us on the same day left Microsoft, started Fermyon, and said, okay, we've got the kernel of an idea. WebAssembly can be the technology for this kind of next wave of cloud computing that'll sit adjacent to containers and virtual machines. And we started fresh and said, all right, how do we envision this working? And we started building. The first thing we decided to do was, as one does, say, all right, we want to start by proving that we can build something production grade in Kubernetes. Kubernetes, in WebAssembly. That trauma is going to live with me for a long time. Build something in WebAssembly that we can run in production on the server and really start to exhibit this. So we built kind of with toothpicks and marshmallows, kind of built our first version of the runtime. And then we built, because this is what we do, we built a content management system in Rust that compiled to WebAssembly that could run in our little first version of this runtime. And it worked. And in February of 2022, we launched Fermyon.com running in a WebAssembly-based CMS on the cloud. We used Nomad instead of Kubernetes. Nomad's an orchestrator from HashiCorp that we just really like. It's a process-based orchestrator. It's really great to use. And then that first kind of toothpicks and marshmallow runtime became Spin a couple of months later. And Spin was our attempt to say, okay, we can build a generic developer tool that will make it easy for the developer. Our core user story, all of 2022, our core user story was, as a developer, I should be able to go from a blinking cursor to a deployed application into a deployed serverless WebAssembly application in 2 minutes or less, right? We just wanted to build a tool that would make it so easy for people to try out writing these kind of WebAssembly on the server side applications that at best they had to invest, a few minutes of their time. I mean, realistically, when you're getting started, everything's a little bit harder, and it probably does take around a half hour, but it was like, actually, you can get the Hello World running by downloading Spin, starting everything up, and you can actually have it running in 2 minutes or less. And that for us was just a really important thing to do. Spin is open source, and so we started layering on additional things. Microsoft, the same people that we kind of left behind, then came back and said, "Oh, we'll help with this," and we started getting more external contributors. The GitHub star count started going up, and we're like, "Whoa, what's going on here?" Right? We didn't think anybody would even notice us yet. And then, over the last, it's been just about a year now, we've seen Spin really take off and grow very rapidly. And we've added from, I think our first languages we supported were just Rust and Go, if I remember correctly. And we figured out a way to sort of do first class support for, kind of top shelf support with SDKs and everything for Rust, Go, TypeScript, JavaScript, now Python. We're working on Java, .NET. The .NET team really did most of the heavy lifting for .NET support. And then we're just kind of working our way through RedMonk's top 20 languages and moving as many over. Mm-hmm. But we also figured by using something that's basically CGI made new again, CGI, for those of you who are much younger than I am, was the world's first attempt at building, dynamic website backends, right? The way I wrote it was a Perl script, and the web server, would get a request and it would shell out to a Perl script and execute that Perl script. It was definitely as safe as it sounds. And then whatever the Perl script spit back out, it would pipe right back to the web browser. And we were looking at WebAssembly and going, actually, if we just support that very basic model, then most of the WebAssembly languages, any of them that supported the standard called the WebAssembly System Interface, most of those languages would be instantly supportable inside of Spin. So from that, we kind of instantly got support for Swift and for now like Prolog and all, sort of some exotic languages like that, new languages like Grain, that's a WebAssembly specific language. And so it's been exciting to kind of see that we can give, a decent experience for a really broad swath of languages, and then kind of a top shelf experience for the languages where we know there are enough developers that we can build a good SDK and give them, start building in things like database support and key value storage support and things like that. So it's been a really fun year as we've kind of seen this little project go from a glint in the eye to something that people are using and finding enjoyment in.
Yeah, that's a both awesome context and really interesting story. So my understanding, I haven't really kept as up to date on WASM as I probably should. The sort of first iterations of that didn't have a good story around like garbage collection, like garbage collected languages. So you really had to use like, compiled language without a garbage collector doing manual memory management. Is that solved within WASM, or do you have to like sort of like build a garbage collector for the languages that need it and sort of like layer that in?
Yeah, this is the
part. Or is my understanding of that incorrect?
I need like the verbal equivalent of an asterisk. It's solved, asterisk. So this has been one of the fascinating issues of trying to write a general purpose language runtime, right? Where anything from Rust to Python to BF to JavaScript should be able to execute inside of this thing, is that languages aren't really built typically with the intent that they will fit a generic model, right? It's going back to the beginning of the conversation, right? We're talking about how languages are really like a reflection of the way we think about the world. And that's true when we're talking about, using a functional programming language versus an object-oriented one. But the very people who design these languages are designing a new language because they want to express a different way, the way they think is the best way of describing these kinds of abstract systems. And so, of course, memory management in Rust, which is I know you had Steve Klabnik on a while back, right? The Rust memory manager is amazing and very, very, very different from the Java memory manager, which is different in turn from the way JavaScript does memory management in Python. And so the first version of the WebAssembly specification just didn't deal with it, right? It said every host language runtime will need to provide its own collection of memory management. And of course, Rust does this very elegantly and was one of the first languages that could easily be implemented this way. This sort of YOLO style of C made it such that C was fairly easy to support. But then you start to hit more complicated languages, more complicated compiled ones like Go. And if you use TinyGo, which is a great, it was a project originally built for embedded Go, but they really have embraced the kind of WebAssembly ecosystem. But they actually allow you to choose different memory management techniques, including shut-off memory management altogether. And you can compile all these into the WebAssembly runtime and have a good time. Scripting languages are a whole different ball of wax, though. And so you get really kind of... And so are the Java languages, right? So you really have three classes of languages. Those that compile all the way down to a binary format and have a kind of slim runtime. Those where the runtime is the scripting interpreter, and then you just feed it in the script files and it executes. And those that are kind of the hybrid bytecode-y ones like Java or like anything that runs on the CLR and .NET. And each of those kind of brings its unique challenges when you're trying to do the one size fits all onto the WebAssembly runtime. So along the way, a lot of the WebAssembly standards contributors began working on a standard memory management extension to WebAssembly that would make it just a little bit easier, so that instead of each language having to implement their memory management inside of WebAssembly, the runtime itself could do the memory management and the language could hook in. That specification is not finished, nor is it really entirely broadly supported yet. But it already seems to be picking up traction. I know the Kotlin team in particular wants to do a Kotlin directly to WebAssembly compile run, and they've really been pushing the new memory management spec. But still, like within the last few months, Python, Ruby, Java, .NET, all of those have had WebAssembly implementations, none of which use the garbage collector specification, each of which again is not widely implemented, each of which kind of brings its own memory manager. And as it's turning out, we're all kind of waiting to see which technique actually turns out to be more efficient. Because when you use a generic memory manager, then there's some amount of contorting your language to fit the abstraction that provides you. And maybe that'll be hyper efficient, or maybe it'll be clumsy. We're not entirely sure. We haven't seen a whole lot of languages support it yet. On the flip side, if you're just compiling your runtime into WebAssembly and you've already got your memory management strategy in the runtime, then to my knowledge, neither the Python nor the Ruby teams did any major alteration of their memory management in order to compile the runtime into WebAssembly. So we'll kind of see, and I think that's sort of the microcosm of the bigger story with WebAssembly, in that we've got a generic runtime that seems to be really well designed and reasonably flexible. We're just now starting to see the momentum build to the point where some of us are kind of sitting there with fingers crossed going, I hope all these design assumptions prove true, because I got a lot invested in this now. And so far it's been I wouldn't say smooth sailing, it's been good sailing, right? Challenges come up, they get solved. Rough drafts get replaced by second drafts, get replaced by production quality code, and things keep looking better and better. It's an exciting time, and maybe this is why we get myopic about how enthusiastic we are about today's technology while less enthusiastic about yesterday's technology. It's exciting to watch this stuff sort of unfurl in front of your eyes, right? And to know that the thing that you banged your head against the keyboard when you ran into it a month ago is now totally well supported and easy to do and trivial. And how come wasn't this easy all the time? And then the things I'm banging my head against the keyboard today, I'm like, I really have to wait another month or two? We're so impatient. But it's been fun. It's a lot of fun to watch this ecosystem develop rapidly. One of the cool things I think about WebAssembly, as a general technology observation, right? We see technologies that are invented for a niche, and then they stay in the niche for their entire life cycle. We see some that are generic languages that then later find their niche. I think Ruby is a good example of that. That was invented to be sort of like a system scripting language. And I think it must have been 5-10 years old before Rails came along, and suddenly Ruby had a reason for existence, and then everybody was doing Rails. And then there are instances like the web itself, right? Or Java, or HTML, which was originally built to transmit physics papers, right? Where suddenly we look at a technology that was designed to do a very small thing and realize that it's general, that it solved for a generic enough use case, or for a generic enough scenario, that there are actually a whole bunch of use cases. And I feel like WebAssembly in the last maybe 12 to 18 months is experiencing that kind of collective realization as we all look at this and go, oh, Fermyon figured out a way to pull this out of the browser and drop it in the cloud. Oh, somebody else, Single Store figured out how to pull this out of the browser and drop it into their database so that they can run stored procedures that are compiled to WebAssembly next to the data instead of selecting it all out, munging it, and then shoving it back in. And we're all kind of discovering these interesting applications where WebAssembly gives us capabilities we didn't have before. And yet at the same time, we're all kind of looking at this going, Fermyon, we're going, we think we have the Rails moment for WebAssembly. We love this serverless application model that we've developed. And meanwhile, Single Store's going, we've found the aha moment for WebAssembly. It's going to be functions in the database. And, XDism is going, we're writing the last plugin system you'll ever need to use, and it's written in WebAssembly. So we're all kind of experimenting, meeting with success here and there, hitting challenges, but also going, what does the future of WebAssembly really look like? Is this going to be a really broad technology? Is it going to find one niche? And is that niche going to, surprisingly for us all, not be anything to do with the browser? So it's fun because things are happening at a quick pace, but it's also fun because we're watching this sort of conceptual explosion of all the different things that can be done with this technology. And we're watching everybody try and find out, is this the right fit to solve this problem that I've had for a long time?
It's interesting. One of the topics we've talked a lot about on the podcast is incidental complexity when we're like developing applications. And, I think like Kubernetes was this answer for this like complex problem of like orchestrating and deploying workloads, but people have like wanted even more simplicity. Is like, look, I don't want to think about this as much. I just want to think about code. And I think the sort of like functions as a service sort of platform movement, AWS Lambda, Cloudflare workers, that sort of thing really honed in people's like, we could have an even simpler developer experience where we sort of like commoditize these resources even further. And I think that it's really interesting that WASM is this more sort of general purpose target at this. Yeah. So it's cool to see it evolve. It's really interesting.
And when you bring up serverless functions that like Lambda or Azure Functions or Cloudflare workers or things like that, that is a case where I think WebAssembly has a real sweet spot that meshes well there. And part of that is because serverless is an idea. Right. Let's talk about serverless functions as an idea, right? It's a way that we introduce elegance to an area where previously there was complexity. Instead of my having to write a full HTTP server with TLS and process management and multi-threading and all of that in order to handle HTTP requests, I just write a function and tell the environment how to call my function and execute it. And then when the call comes in, my function starts up, is given the request, processes it to completion, spits back out a response, and shuts down, right? Now, earlier I was talking about how one of the things we were after was scale to zero, and WebAssembly provided scale to zero. Functions as a service is a quintessential scale to zero architecture, or ideally, right? In the abstract, it should be a scale to zero architecture. The way that we got to the first wave of serverless functions, though, was a little bit clumsy because we didn't have, Lambda was built without WebAssembly. Lambda's built on top of a virtual machine architecture, which, as we talked about earlier, is really the slowest of the cloud compute primitives, right? It's the one that a decent-sized virtual machine can take minutes to stand up. And so there's all this optimization behind the scenes on platforms like Azure Functions and AWS Lambda and Google Functions that are designed to sort of pre-warm things and get them all queued up and be ready. And every time you start using words like queuing things up and pre-warming, we hear in the back of our heads, oh, waste, right? More electricity is being consumed. Computers are sitting idle when they could be doing something. Somebody's engineers are having to run those things and the rest of us are having to pay for those things. The typical Lambda function still, even with all these optimizations, right, still takes around 200 to 500 milliseconds to cold start for most of the tier 1 AWS languages, right? As we already established, 100 milliseconds is when your user starts losing interest, right? So already we're outside of the bounds of where the user's natural tolerance. And so for that reason, I think Lambda hasn't really or any of these serverless functions things haven't really quite hit stride with being able to be full-on web backend platforms, right? We've managed to cobble together things such that it's satisfactory, but cobbling doesn't feel nearly as nice as, finely crafting, right? And I think WebAssembly is providing a very interesting avenue for us to start building beyond that first version of serverless functions into one that our WebAssembly startup times right now are about 2 milliseconds and under. Really, our average one is under 1 millisecond to cold start before it's executing user-supplied instructions. And that's the kind of profile you want if you want to have a page that serves out and gets a 99 to 100% on the Google PageSpeed rank, right, and scores well on SEO. And that's exciting. WebAssembly's got something to offer here that we can do in addition to, the security, the package size, and that kind of thing. So I think that serverless applications, right, serverless functions are one of those places where we at Fermyon, building tools like Spin, can really make some vast improvements and say, look, here's a promising first step for why WebAssembly is this kind of third wave of cloud computing that's going to be able to speed up the performance, speed up the development process, support a wide variety of languages, and then as WebAssembly itself matures and we get things like the component model, we're going to be able to build very interesting and sophisticated applications using WebAssembly for all it's worth, right? And one of the things that's exciting to us is right now you can build a WebAssembly serverless application using whatever languages you want.
That's a great example of the technology. Before we move on to tooltips, let's talk about Fermyon a little bit. Talking about hosted platforms, you built a hosted platform, so why would you use Fermyon, and what is it?
I mean, doesn't everybody just build a hosted platform? Isn't that what we're doing until the world is full of? No, we wanted to build. Spin is this developer tool to show people how to build WebAssembly applications. We really wanted to build a place that could execute these and show, and we wanted to do it in such a way that it would be trivially easy for people to try this out on their own. So we've got an open source, full packaged up Nomad console, Vault, Spin, all of that kind of stuff where you can install it into whatever your cloud provider or bare metal is. But that's a time consuming process. It's going to take you a while to get it set up. Then you're going to have to maintain it thereafter. We really wanted to provide developers with that experience where they could try it out nearly instantly. Right. Again, going back to that core user story, we wanted to go from blinking cursor to deployed application in 2 minutes or less. And so 66 seconds or less is what we are now down to. So, you type in a command, spin new, it scaffolds out your project. You can do spin build, it builds your WebAssembly module. Then you do spin deploy, and it pushes it up into Fermyon Cloud. And then you get your domain name back, and you can start playing around with it. And that's essentially that's where we are now, right? It's a free platform. It's open beta. Eventually and it's kind of rate limited at this point because, when you get 1,000, 2,000 applications on there, you do kind of have to watch the budget. But I think we'll kind of evolve this into the kind of thing where if Fermyon platform is scratching the itch you have, then for a few bucks a month you can upgrade your plan, run all the finicky whiskers and slats games that you want to, build whatever you want to as a serverless application. And if it's really more your thing that you want to manage your own platform, there's still Spin and Fermyon platform, all open source that you can kind of do your own thing with.
Yeah, I think it's commendable that you have all of the tech essentially open source. So like if you want to go host this yourself, you can. I think that's super cool.
I think that was actually one of the things we learned to do well at Microsoft of all places. When you think about Helm, right? We never attempted to monetize Helm at Microsoft. The only goal of Helm ever was to make it easier for people to get the job done that they cared about, which in Helm's purview was packaging up that YAML and making it possible to reuse the same packages to install your software on as many different Kubernetes instances as you ever wanted to. But what we observed there was when you give people a tool like that makes it easier for them to build the things they care about, then they build more stuff using your platform. And, AKS was the fastest growing service offering in all, AKS being Azure Kubernetes Service, right? Fastest offering in all of the Azure catalog, right? There are hundreds of different application types and services in Azure, and AKS was one of the fastest growing. And the reason why I'm utterly convinced is because we as an ecosystem provided a whole bunch of open source tools that made it compelling. It was easy to move first my little application, then my databases, and then the monitoring stack and all of that into Kubernetes using tools like Helm. Definitely not exclusive to Helm, but it was one of the enabling tools. So as we looked at Fermyon, we said, we're all a bunch of open source developers anyway. But we really like to apply that learning where we really want Fermyon Cloud to be the easiest, best place for people to run Spin applications. But they're not all going to find their needs met by that, right? Some people, for regulatory reasons, need to run things on their own hardware. Some people will want to run it on a skiff or on-prem or in DigitalOcean instead of us. And we want them to be able to do it. And Spin we are successful at Fermyon if we can really articulate that vision and people say, oh yeah, this vision is great. This vision is really compelling. I love it. Right. And we do want to be able to pay everybody's paychecks eventually. But we understand that, in a sense, all of us as software developers are actually in it for something a little bit bigger than that. Right. We really want to go in all the way back to the beginning. Right. We're passionate about trying to show people, look, I've constructed this mental model that I think if you use it, it's going to make your life easier. It's going to make your day a little less stressful, your weekends a little less full of pager interruptions. And that, that is really the kind of driving thing behind us as software engineers at Fermyon. We want to give people that experience. What we found that we love about WebAssembly, we want other people to be able to try it and then use it the way they want. And we hope that Fermyon Cloud ends up being the kind of thing that people want to pay for. But if they don't, there's Spin, there's Fermyon Platform, and they're part of this big community that's going to keep pushing this technology forward.
Great interview so far. It's been a pleasure having you on. With that, we'll move on to tooltips. Want to hear the full interview and all of our tooltips? Head over to Patreon and subscribe. Awesome. Well, that wraps it up for tooltips. Matt, thanks for coming on. Neither Justin or I are the biggest backend or Kubernetes guys, but I think you explained everything in a very concise and very interesting way. I'm really excited for this episode to come out. It was a lot of fun talking to you.
I feel like, again, I should apologize for everything, for all the bad software I've created. But also, as we talked about, maybe I'm just being hard on myself. Present me is hard on past me.
It's one of those things where we have to have people to pave the path to the better future. And that creates, you just got to build a lot of tools to get there. And, we both appreciate the work that you've done. I have experienced the joys of Helm personally. So, not having to rebuild a lot of things. I appreciate the work that you've done. This is such a fun episode. Really appreciate you coming on.
Yeah, this is a lot of fun.